This is Fundamental Problem 1 from Chapter 17. The cart and its load have a total mass of 100 kilograms. Determine the acceleration of the cart and the normal reactions on the pair of wheels at A and B. Neglect the mass of the wheels. If you go back a few pages in your textbook, for equations 17-11, they give you 4 equations here. The first 2 equations are just Newton's second law, and the third equation and the fourth equation, it's this or this equation that you can use. Those are equations 17-7 and 17-10, and use either one of these equations in this case. Okay, so let's start off by drawing our free body diagram. So this is wheel B and this is wheel A. So I have the normal reaction for wheel B and wheel A. And I have a force of gravity which acts at the mass center. So this is M times G. And they give me this force here, and this is a 3, 4, 5 triangle. So you have this 100 Newton force. And because it's a 3, 4, 5 triangle, the force acting straight downwards is 60 newtons, and the force, the component acting to the right, is 80 newtons. Okay, so we want to find the acceleration and we want to find the normal reactions. So we have 3 equations we're going to use to do this. We have Newton's second law applied in the x direction, so the sum of the forces in the x direction is equal to the mass times the acceleration of the center of mass in the x direction. And sum of the forces in the y direction is equal to mass times the y component of the acceleration of the center of mass. And we are going to use here also equation 17-7. Okay, so first let's look at the x components. So I have one force here. Maybe I should make this red also. So I have one force here which has a component in the x direction. That component is 80 newtons. So that gives me 80 newtons is equal to the mass, which is 100 kilograms, times the acceleration. So the acceleration is equal to 80 newtons divided by 100 kilograms, and that is 0.8 meters per second squared. That's the acceleration that they asked us to find. So the cart is only moving in the horizontal direction, so the x component is the acceleration. Okay, so then we can look at Newton's second law in the y direction. And in the y direction, we have NA and NB acting upward. And we have the force of gravity acting downwards. The mass is 100, so this is plus 100 kilograms times 9.81 meters per second squared. And then we have a component of this force which is acting downwards. This is acting downwards also, so that should be negative. And that component is 60 newtons, so that's minus 60 newtons. The acceleration in the y direction is 0, so that's equal to 0. Okay, so we have 2 unknowns in this equation. So we're going to need a third equation in order to find our 2 unknowns here. So we have the sum of the moments of the external forces is equal to the moment of inertia times the angular acceleration, but the angular acceleration here is 0. So we have the sum of the moments is equal to 0. And so if we go back and we look at our picture here, if we do the sum of the moments about point G, the force of gravity is acting at the mass center, so that is 0. Then we have the normal reaction at A, and that causes rotation this way. So this is NA, and that's acting in the, that's causing rotation in the positive direction, and that's times 0.6 meters. And B would cause rotation in the opposite direction, so that would be negative. So it's minus NB, and this distance is 0.4. And then this force has a vertical component and a horizontal component. So if you look at the vertical component, that would cause rotation this way. That's in the positive direction. And the distance in the x direction, that's 0.4 plus 0.3. So that's, what was positive? So it's plus 0.4 plus 0.3 is 0.7. And this was 60 newtons downward. So that's 60 newtons times 0.7 meters. And the x component would cause rotation in the negative direction. So that's minus, and this is 80 newtons. And the distance in the vertical direction from the mass center to where the force is acting, this whole distance here is 1.2, and this is 0.5. So that is 0.7 also. And because the angular acceleration is 0, this is equal to 0. So let me simplify this. I'm going to leave the units out here also. So 60 times 0.7 gives me 42. 80 times 0.7 gives me 56. Okay, and then I have my equation up here, which came from looking at the sum of the forces in the y direction. And let me write that as NA plus NB minus 981 minus 60 is equal to 0, or I could write that as NA plus NB. 981 plus 60 is 1041. I'm going to bring that over to the other side so it's positive. Okay, so now let's call this equation 1, and we'll call this equation 2. You can solve those two equations however you want in order to find your two unknowns. Because I have a 0.4 times NB here, and I'm subtracting that, I'm going to take equation number 1 and multiply by 0.4 on both sides. So I have 0.4 times NA plus 0.4 times NB is equal to 0.4 times 1041. And I'm going to take this equation and I'm going to add it to equation number 2. So if I do that, I add everything on the left-hand sides for the two equations. So that's 0.4 NA plus 0.4 NB plus NA times 0.6. So that's this side of the equation here plus this side of this equation. Then I add the two right-hand sides of the equations together. But this was just 0. Then I have plus 0.4 NB minus NB times 0.4. So those cancel out. 0.4 plus 0.6 is just 1. So this is NA. And 42 minus 56 is negative 14. And 0.4 times 1041 is 416.4. So NA is equal to 416.4 plus 14, that's 430.4. And that was something they asked us to find. And so then going back and either using equation 2 or equation 1, I can find NB. It looks like it's going to be easier to do that using equation 1. So using equation number 1, NB is equal to 1041 newtons minus 430.4 newtons. So I get NB is equal to 610.6 newtons. And that concludes fundamental problem 17-1.